Now starting with the last type of solid, which is cone. Now as I told before, cone will be asked for 3 stages similar to pyramid, but um, pyramid is more frequently asked compared to cone, so practice more for pyramid. Cone will be also easier and somewhat similar to cylinder. In case of cylinder, we were getting rectangular faces, but in case of cylinder cone, we'll get triangular faces. Only that much difference. And circular base will be common. Instead of 2 bases in case of cylinder, I'll get only 1 base here for cone. And for apparent view, I'll get for circle, I'll get an ellipse. So that part will be similar to cylinder. Okay, and here we are also going to get the triangular face in one of the views. So we'll start with the first problem. So draw the projection of cone, base 50 mm, axis 60 mm long, when it is resting on HP on a point of its of base circle with the axis making angle of 30° with the HP and 45° with the VP. Now here two inclinations are given, both with HP as well as VP for the axis, since it is a 3-stage problem. Now we need to see where to start and how to start, how to draw the base. So initially it is given as that cone is resting on HP on a point of on its base circle, okay, on the HP. So we will first assume that entire base, which is circle, is resting on the HP. So that can be seen as a true shape in the top view. So again I need to start below XY line first. So first I'll start with the circular base, which can be seen below XY line, true shape in the top view. So we'll start with drawing a circle. Since base is 50 mm, so we will take radius as 25 mm to get 50 mm diameter for the base. So we'll draw a circle of 25 mm radius. Okay. Now the next step is to divide the circle into 8 number of parts, since the circle is small, as we have done in case of cylinder. Then a vertical diameter, or you can directly divide with 45° angle. Okay, so we'll mark those angles 45, then 90, and again 135 to divide the base of the cone into 8 parts. Now this division on the circumference is required to get ellipse when we draw the next views, because when the cone will be tilted, that circular base will appear as an ellipse, and for drawing the ellipse as a smooth curve we need points in between. So we'll start numbering 1, 2, 3, 4, 5, 6, 7, 8. Now in case of cylinder there were 2 bases, top base and bottom base. So along with 1, 2, 3 we also mark ABCD there, but here since it is a cone, we'll get only 1 base, and that center of the circle will be the apex or center of the circle. So we can say OO. One is for center of the circle and one O is for apex. Now we'll mark the axis height, which is 60 mm. So we'll produce this vertical diameter, and from the XY line I'll measure 60 mm to mark the axis, and we can draw it by long dash short dash, because there is no question of slant edges. So only the boundary which is a triangular in shape, will be visible. Rest all the points will give me the imaginary generators. So we'll drop the projectors from remaining corners. So 4 to 6 will coincide. Then 5, then 2 to 8 again coincides. Then last is 1. Okay. Now we'll join the boundary. Now we are getting apex at the top, so I'll get a triangular shape in front view. So for that, boundary is dark. In case of cylinder we got rectangle, but in case of cone we'll get a triangle. Now as in case of pyramid, there will be no slant edges in between because it is a curved surface. So we have marked some more divisions on the circle, so those will give me imaginary generators as in case of cylinder. So those lines should be light lines. And the generators from 3 and 7 are coinciding with the axis, which is already shown with long dash short dash. Now we'll give the corresponding notation: O dash as the apex, O dash as the center of base, then 1 dash here, 2 dash, 8 dash, and here 3 dash, 7 dash, and O dash, here 4 dash, 6 dash, and at the end 5 dash. Okay. Now this completes the first stage. In second stage, we are going to redraw the front view. So we need condition with the HP. And for the HP, the condition is given axis making an angle of 30 degree with the HP. So we need to make this axis O dash inclined at 30 degree in the next stage. But while doing that, we need to keep one point on the circle still on the HP. So here the point is 5 dash. So first I'll mark the 5 dash to keep it in HP. So we'll keep that point still in the XY line, on the XY line. But now from 5 dash we can't directly start with the axis. Okay, 5 dash, with 5 dash we can draw only the base. Okay, and we know the relation between base and the axis, that they are perpendicular. So if axis is inclined at 30 degrees, so obviously the base will be inclined at 90 minus 30, which is 60 degree. So with 5 dash, instead of marking 30 degree, we will mark 60 degree to draw base first. Then after drawing perpendicular axis to the base, that will obviously give me angle of 30 degree. So first I will draw angle of 60 degree to mark the base on that. Okay. So I'll take this base 5 dash to 1 dash on that 60 degree line. Then we'll complete the rectangle, complete the triangle by marking the apex O dash. This distance and this distance will be same. Okay, so from 5 dash I'll take one arc, and with the same distance I'll take one arc from 1 dash. So that will give me a triangle outer boundary which is dark. So I'll make that triangle dark. Now inside the triangle we need to mark imaginary generators and the axis. So we'll mark these divisions in between by taking the distance in compass. So 5 dash to 4 dash 6 dash will be same as 1 dash to 2 dash a dash. So I will take the same distance from both the points and will mark the arc. Then the center point 3 dash 7 dash O dash. So we'll give the notations 4 dash 6 dash, 3 dash 7 dash O dash, and 2 dash 8 dash. Now we'll join by light lines since they are imaginary generators. Now the last thing is axis, marking the axis, long dash short dash. Okay, O dash O dash. Now we'll complete the corresponding top view by dropping the projectors. Then from top view, horizontal projectors parallel to XY line from each point on the circumference. So here 7 and 6 and 8 will coincide, projector from 6 and 8. Then the center horizontal diameter. Then 2 and 4 will again coincide. Then finally 3. Okay. Now we'll mark the points. So 1 dash and 1. So you'll get 1 here. 2 dash 8 dash here from this projector. So 8 and then 2. Then 3 and 7. Then 6 and 4. And finally 5. Then center of the wave on this line and from this projector. So O will be here. And finally the apex will be here. Now for cone, this base which is appearing a straight line in this view is nothing but a circular base, but after tilting from top view it will appear as an ellipse. Now first I'll join all the points on the circle 1 to 8 by smooth light line. So I should get a shape of an ellipse. Then after doing this, I'll decide which part to make dark and which to keep dotted. Observer will look from this direction. For the observer now the entire base is not visible because only part visible will be above this point, okay, and this point. So for the observer the entire base is not visible, but by rules of visibility, if any part is lying on the boundary, then that will be made as dark. So this portion which is lying on the boundary means 3 to 7 will be dark, and the portion inside that which is not on the boundary will be dotted. Okay, now we need to join apex with the tangent point, not with the 3 but tangent point, because observer can see only the tangent. So I'll not be able to join up to the center, so tangent is meeting before that. So this will give me the boundary of the tilted cone. Okay, so we are joining only up to the boundary, the tangent point to the ellipse. So it can be between 6 and 7 also, not exactly meeting at 7. And then at the end we will show the axis O dash O dash, OO by long dash short dash. Okay. Now this completes the second stage. Now for third stage, we need to redraw the top view, and for that we need condition with the VP, and the condition given is axis making an angle 45 degree with the VP. Okay, but this angle was theta. Okay, because we marked base first at 60, so obviously the axis will give me 30. So theta is given as 30. Now this 45 degree is the true inclination phi for the axis. But now after redrawing this top view, if you check the length of the axis O dash, it has got shortened. That means it is not the true length of the axis, but it is the apparent length. For apparent length, we can't use the true inclination. For that, we need to calculate the apparent inclination. Okay. So as done in projections of solids. So first, I'll mark the true length on this true inclination. The true length is here or here, which is same as the axis length, 60 mm. Okay. And then we will mark the apparent length to get the apparent inclination. Now here, before doing that, we need to decide the orientation. That means in which direction should we rotate that top view, clockwise or anti-clockwise. For that, we should look for any condition given in the problem, whether the apex is nearer to the observer or away from the observer, but no such condition is given. So we will rotate this top view in clockwise direction such that apex will come below, nearer to the observer. Okay. So while doing that, we need to first calculate beta. Here phi is given. This is the true inclination with the VP, but we want apparent inclination because we want to redraw the apparent axis length. So for the method for that is, first I'll mark this true inclination 45 degree. Okay, and on this 45 degree, I'll first mark the true length of the axis, means this length, which is 60 mm. Okay, so I'll mark this true length, suppose O1. Now I'll draw the locus from O1 on which I'll cut the arc for apparent length of the axis. So that will give me the apparent angle. Same as that done in projection of solid. Okay. So after drawing the parallel line to X by passing through O1, now I'll actually mark the apparent length, keeping this center of the base fixed. So I'm getting somewhere here. So this angle was 5, given as 45 degree. Using this angle and true length of the axis, we have marked the apparent length, and if I produce this apparent length up to XY, then I'll get the apparent inclination. This will be beta. No need to measure that. We can directly start now. We are using this apparent length of axis, which is inclined at now beta. Okay, so now we'll redraw with this axis. So for that, first I'll enclose the entire top view in a rectangle. Okay, now we have marked this point, so we need to further go this much distance on this side of O, and on the line of beta, don't mark on the line of true inclination. Okay, now at this point we will mark, and this point and this point, this is the final position of O. So we will draw one perpendicular here and one perpendicular here. That will give me these two edges of the rectangle. Then after that we will complete the rectangle. So we have first marked this length O21. So this point will give me 1. Now using this we will complete the rectangle. For that, first I need to draw the perpendiculars at 1 and O. So some part will be extended here and some part will be extended on other side. So first we'll draw the perpendicular at one side. So here you can extend it on this side also. So after extending, we can extend these perpendiculars on this side also from 1 . Okay. Now we'll mark from 1. I'll mark this distance on both sides to get the boundary of rectangle here as well as here. Same distance can be marked with respect to O. So this will give me this rectangular boundary in which the entire top view is included. So we have drawn this rectangle. Now we'll draw this ellipse and the tangents in that. So after doing this, now we'll mark 1 to 5 on the same line, center line. So here I'll get 5. Then for 3 and 7, we can take the distance from this corner, which are lying again on the boundary, 3 and 7. So from both the corners, I'll mark. So this will be 0.7 because we are tilting like this, and this will be 3. Okay. Now further we need to mark 2, 8 and 4, 6. So if I draw these parallel lines at passing through this distance and this, then we'll be able to locate these 2 points. So for that, I'll take those parallel distances. Better to take maximum distance. So from O I'm getting the maximum distance. That will not give me the error. So from O I'm marking the parallel line for arc for parallel line for 2 and 8. Similarly, I'll mark the parallel line for 4 and 6. Okay. So we will draw parallel lines. On this line only we are going to get 2 and 8, and on this line we are going to get 4 and 6. Now we can take only one distance and mark all 4 points, because if you see from the center line, the distance for 8 is same as distance for 2. Again, that distance can be taken for 6 and 4 also. So from the center line, I'll mark 4 arcs on the 2 parallel lines to get the remaining points on the ellipse. Similarly, for this parallel line. Okay. Many of you find this step difficult for redrawing the view in third stage. So you follow this rectangle method, that will be easier. So this will be 2, this will be 8, then this point will be 6, and this point will be 4. Okay. Now we'll again join, keeping the same visibility by smooth curve. Okay. Outer boundary dark, inner portion dotted because not visible to the observer. Okay. Now we'll draw the tangents. Not exactly meeting at 3 but before 3, and here the tangent not meeting exactly at 7 but before 7. Okay. Now after redrawing this stage, we'll complete the final view by usual method, dropping the projectors from each corner and corresponding projector from front view. Be careful while using the roller scale. So first point 3, then 2, then 1. Sorry, we missed 4 in between. So 4, then 1, then center of the base O. Here we need to be careful while marking the points because lines projectors are too closely placed. So be careful. Then 8, then 6, and finally 7. Okay, and then vertex. Now we'll project from front view now. Two dash 8 dash 1 dash and O dash. Okay, now we'll mark all the points. So starting with 5, which is lying on the xy, so corresponding projection from top view is here, so 5 will be here. Then moving to 4 and 6, so first I'll go for 4, point will be here, and 6 for 6, the corresponding projector is here, so 6 will be here. Then 3, 7 and O, so for 3 it is the extreme outer projector, and here, and 7 again extreme outer projector here, so 7, and for O it is the center O. Then 2 and 8, so 2 projector is here, so I'll get 2 here. All notations are with dash because it is a front view. Okay, then 8 from here on the same line, 8 dash, then 1 dash, the same projector here, and sorry, 1 dash. See, we have done a mistake of marking 2 dash and 8 dash. By mistake, we marked it on projector from 1 dash. So 2 dash and 8 dash should be below. So 2 dash is on this projector and 8 dash is again here. Now for 1 dash here, so this line, so 1 dash will be here, and then finally apex O dash here. Okay, now we'll start with joining all the points in sequence 1 to 8 by smooth curve. Then we will decide which part is dark, which part is dotted. Six to 7, 7 to 8, 8 to again 1, and finally 2 to 1. Okay. Now with O dash for boundary, we need to join till the tangent point. Not any division among 1 to 8, but we need to look for tangent point. So I am getting a tangent point here. Okay. Similarly, other boundary, tangent here. Now, boundary of the ellipse, the part of the ellipse which is lying on the boundary will be dark. Okay, now we'll see for this portion 1, 7 and 8. So observer direction is this. So 1, 7, 8, this portion is farthest from the observer, so it will be dotted, not visible to the observer. So this portion of the ellipse will be marked dotted because it is farthest from the observer. Okay, then finally we need to show the axis. Here also we have to show the axis long dash, short dash. And in this view also. So due to this complexity of ellipse, many of the students find it difficult to handle the problems of cone. But if you do with proper visibility rules, then it is easy. So finally we need to show the dimensions. So first is the diameter of the circle. This can be shown like this, which is 50 here. Then axis height, which is 60 mm. Then this theta we have already marked 30 degree, and 45 degree phi is already marked, but that is for true axis length, true inclination. So initially we marked apparent inclination because we need to plot apparent axis length. So this completes the solution.